Problem solving with quadratics. You ready? Problem solving with quadratics. What we're using today is the vertical motion formula. Okay? Now, I need you to understand that there is not one vertical motion formula. There's not. Okay? Because this one's in meters. There's a different one for feet. Right? There's a different one for different situations. But I will tell you today, we are all using that formula. All of us. Okay? All of us are using that formula. You're right with that? If I want you to use a different formula, I promise I will tell you. Is that fair? Okay. So we're going to start off with problem number 1. Okay? Now, while we're using this formula, it's a general formula, and we need to write a specific formula for every one of our questions today. So we're going to start with this formula, but have a different one for every one of our questions today. Okay? A football is kicked into the air with an initial upward velocity of 25 meters per second. So Austin's kicking a football, right? Okay. With an initial upward velocity of 25 meters per second. If I go back to this vertical motion formula, where am I going to put 25? For R. So for this particular problem, we're going to be using D equals 25t minus 5t squared. You okay with that? Okay. So problem A. Problem A says calculate its height after 2 seconds. What am I doing? Where does the 2 go? For the t, right? Isn't t the time? So 25 times 2 minus 5 times 2 squared. Order of operations says I start where? Exponents, right? Okay, so 2 squared. 4 times 5, 20. What is 25 times 2? 50, and what's 50 minus 20? 30. 30 answers the algebra. What answers the question? Calculate its height after 2 seconds. 30 what? Meters. Oh, sorry, I wrote in cursive. That doesn't say metons. Oh my gosh, you guys judge my writing so much. Part B, calculate its height after 3 seconds. Okay, so 25 times 3 minus 5 times 3 squared. Ethan, can you get that, please? What is 25 times 3? 75. Okay, what's 3 squared? 9 times 5. And 75 minus 45? 30 what? Let me try a little better. Is that better? Okay, if you don't mind. Thank you. All right, so remember what this is called, right? What's this called? Vertical motion formula. This is not called horizontal motion. I need to make sure that you understand that the ball is not flying up in the air to 30 meters and then holding at 30 meters and then coming back down. Do you understand that? The ball is going up and coming back down, right? And at some point where 30 meters is, this is what? 2 seconds. And this is what? 3 seconds. Are you asking me when it gets to the highest? Yeah, I would agree with you that it's 2.5. Okay? It's not something it asks us, but that's a good thing to know, just to observe, right? Okay. We okay so far? Are you asking me how is this math correct? It's allowed to be weird. It's math. No. She's fine. If you understand, you don't listen to her. Okay. What about C? Part C. When will it be 20 meters above the ground? Is that a time? Oh, that's a distance, right? So 20 is going to go in for our distance this time, right? So 20 equals 25t minus 5t squared. Got it? Okay. What should we do? Can I square root? No. Because remember, if I want to square root, there has to be no x term, right? Or in this case, a t term, and we've got one, so I can't square root. So you want to get it equal to 0? I think that's a very good plan. Okay, so if we get it equal to 0, let's subtract 20 from both sides. Okay, now is it all right in our next step if we go ahead and get it in order? Okay, what should the order be then? How do we know that's the right order? And -5 is the biggest? Oh, the exponent. My t squared is the biggest, and then my t, and then my constant, right? Okay. Now, how many options do we have from here? Yeah, we said we had 5, but we know we can't square root, so that's out. Do you really want to graph this? No, so what's left? Completing the square, quadratic formula, or factoring, right? That's what's left. It might be easiest if the first thing we do was factor out a -5, right? If I divide both sides by a -5, why would that be easier? Yeah, it would make my numbers smaller, wouldn't it? And they're all divisible by 5. Now, why didn't I just factor out a 5? I want my t squared to be positive at all possible. That's excellent. So 0 equals t squared minus 5t, perfect, plus 4. Now we can decide, do we want to factor, do we want to complete the square, do we want to do quadratic formula? I'm always going to check first to see if I can factor it, because I know factor is pretty quick if it works, right? My leading coefficient is 1, so I know I can do my trick. What multiplies to be 4 and adds to be -5? Oh, there's stuff, right? -1 and -4. So let's go ahead and factor it if that's okay with you guys. Zero product property says if I multiply two things by each other and I get a 0, what do I have to do with each one of those factors in order to solve it? Set it equal to 0, right? So if t minus 1 equals 0, what does t equal? 1. And if t minus 4 equals 0, what does t equal? Because remember, we add 1 here, add 4 here, add 4 here, right? So now I've come to the end of the algebra. Now I have to answer the question. When will it be 20 meters above the ground? Remember, there's a random place over here that's 20 meters. Oh, wait, so both of them are the answer? Yeah, right. Look at the graph that we even drew. 1 second and 4 seconds. It crosses that parabola twice, doesn't it? So doesn't it have to have two answers? Yeah. So 1 second and 4 seconds. What if I just put 1 and 4? Yeah, I would get points off for that, wouldn't I? Because I didn't answer the question. I answered the algebra, but I didn't answer the question. Okay? Last part. When will the ball hit the ground? When will the ball hit the ground? If we're looking at our graph again, didn't the ball start here? And the ball is ending here? If you're remembering that this is the vertical motion formula, vertical motion, how high above the ground is the ball when it hits the ground? So 0. So my distance in part D is 0. 0 equals 25t minus 5t squared. Now this one's much easier to solve, isn't it? Because I can go ahead and put it in order right now. But I also notice that they're both divisible by -5, so let's divide everything by -5. So 0 equals t squared minus 5t. But then I also notice that I need to factor out a t, right? The greatest common factor is a t. So I get t minus 5 times t. Well, isn't that factored all the way now? Zero product property says if they multiply together to equal t, what should I do with each factor? Set it equal to 0. T equals 0 and t equals 5. I've answered the algebra. Now let's answer the question. When will the ball hit the ground? So you're going only with one answer? Very good. Okay. This is when we started. It's asking when it's going to hit the ground. The only answer is 5 seconds. Any questions about that? Okay. I've got to take my headphones off for just a second and then try to talk loud enough so you can still hear me. Okay? Because I have to move away from my desk. We had a discussion at the beginning of the school year, somewhere around September, and we were talking about distance, and we got a negative answer. And we said, can we have negative distance? And you guys said, no. And I said, we'll argue about that later. And then we went on with the lesson, right? Well, today's later. Okay? Today's later. So, how far is the chair below my feet? The chair. 0, right? Because I'm standing on the chair, right? So the chair is 0, like meters below my feet, 0 feet below my feet, right? How far is the ground below my feet? Maybe 2 feet, right? Is that a negative distance? No, a distance is a positive number, right? But is it a distance below where I am? So how would that number show up in the problem, in the algebra? It would show up negative, right? So can I get a negative number for distance and it still be the right answer? Yes. Always? No, not always, right? Because if I'm standing on the ground and I get an answer of -2, I can't have -2 feet below my feet. That's the ground, right? This is where I start. We can't go underground. I mean, you can, but I'm not going underground, okay? But if we're talking about I'm standing on a chair, or I'm standing on a desk, or I'm standing on a building, or I'm standing on a bridge, can I have distance below where my feet is? Yes. Can I have negative time? Yes. It's a trick question, isn't it? Can I have negative time? No, we don't have negative time. But how long ago did the bell ring? 20 minutes? 15 minutes? And how would that show up in a math problem? As a negative number, right? So we need to be able to interpret if we get negative numbers for time and for distance, okay? I'll tell you right now on some of these problems that you have that you're going to do tonight, you're going to get a negative number for time and a negative number for distance. And sometimes that negative number will make sense in the context of the problem. Like when I was standing on the chair and it was 2 feet below my feet, right? But sometimes I'll get a negative number for distance and I'll have been standing on the ground and that won't make any sense. Does that make sense? Sometimes I'll get a negative number for time and it'll make sense because I'm talking about how long ago something happened. But sometimes I'll get a negative number for time and it won't make any sense because of the context of the problem. So I just wanted to prepare you for that. Okay, now would you please turn your worksheet over to the back? Yes, sir. Absolutely. 100%. Now, what's the title of this worksheet? Of this side, I mean. Oh, discriminant. We have some things we need to remember. What is the discriminant? B squared minus 4AC is the discriminant, yes? And what else do we know about the discriminant? If it's positive, what kind of solutions do I have? 2 real, right? What else is a possibility? And what would make 2 imaginary solutions? If I get a negative discriminant, I have 2 imaginary. And what's the other option? Which would give me a 0, which would give me 1 real, which is a double root. Do you remember that? Okay. If you don't remember it, or if you didn't a minute ago, do you now at least? Yes? Okay. So I want you to keep that in mind. We're not trying to solve the ones on this page. We are just using the discriminant on the ones on this side. Okay? Same vertical motion formula. Okay? So let's talk about problem number 1. The target plane, what is the target plane? The target plane flies at 2100 meters. There's the plane. I know you all wish you were as good an artist as I am, but that's okay. You can be someday. Okay? A target plane is flying at 2100 meters. An anti-aircraft gun fires a projectile with an initial upward velocity of 200 meters per second. Will the projectile ever reach the altitude of the target plane? First of all, I need to substitute in what I know. Okay? What do I know for this problem? Do I know D? Do I know the distance? What is it? 2100. Do I know the rate? What is it? 200 meters per second, right? So 200t minus 5t squared. If all we're finding is a discriminant, I need to get it equal to 0. Exactly right, okay? So I'm going to subtract 2100 from both sides. And I'm going to go ahead and write the equation in standard form, right? So negative 5t squared plus 200t minus 2100, because that's easier to identify A, B, and C, isn't it? Okay, so in this problem, what's A and B and C? So B squared minus 4AC would be 200 squared minus 4 times negative 5 times negative 2100. Now, I see the looks I'm getting, okay? Because some of you are like, why didn't we take out a greatest common factor? Guys, that's a very fair question, okay? But I'm not trying to solve this. I'm just trying to find the discriminant. And I know all I'm going to do is punch in the calculators, the calculator doesn't care how big the numbers are. Okay? So I'm going to say 200 squared minus 4 times negative 5 times negative 2100. God bless you. I got negative 2,000. Negative 2,000 is the answer to the algebra. What answers the question? Will the projectile ever reach the altitude of the plane? No. That's the answer to the problem. This is my work that proves this is the answer to the problem. Why is the answer no? My answer was negative. 2 imaginary means that the parabola never gets to the target height. Does that make sense? So if it was a positive number, what would the answer be? Yes. And if it was a 0, what would the answer be? Yes, right? It can still get up to that height. It only has one chance, right? But it can still get up to that height. Does that make sense? Do you have any questions about that? God bless you. Anybody have any questions? Okay, you guys are doing the rest. Okay,